Before we continue with the idea of measures of location, we're going to take a little detour and we're going to look at a type of notation used for adding up lots of things, which you might be able to see that's going to come into it when we're calculating things like the mean when you add lots of values up. So this is called summation notation, and I want you to just be a bit creative to start with. Don't look this up, don't try and cheat, but think, how could we write six things added together as shown, x1 plus x2 plus x3. How do we make this more concise, i.e. convey exactly the same information but through much briefer means? Because if I had to add up 100 values from 1 to 100, then I'm going to have to write loads down as a way of doing it really quickly. And I'd be really interested to see what you come up with. What mathematicians came up with in the past is the following. They use this to indicate sum. That means I'm going to add lots of things together. And then what am I adding together? I'm adding lots of x's together, but each time this little subscript, which we call an index, is changing. So I'm just going to give this a little symbol. Maybe I'll call it n. So this is called the index. And x is, I don't know, is x my variable? It's the thing that's staying the same in that case. And then how do I convey that I'm going from 1 to 6? Well, what I do is I just put a little 1 at the top, and then I put a little 6 at the top. I just need to say what is changing, and it's actually the n that's changing. So my n is not actually in my final answer, and it's also sometimes known as a dummy variable. Okay, there's a lot that I've said here, but essentially, this thing here is exactly the same as this thing here. Sometimes people write n equals 6 at the top as well, but it's not really needed because it's it's basically implied. And this is the idea of summation notation. Just going to show one that I made earlier. So yes, this is a summation sign, and if you want to know a bit more, it's actually capital sigma in the Greek alphabet. So I've given it a capital S, but I should maybe just say, yeah, capital sigma. We've got our starting points here is 1. We've got our stopping points. We've got it's called a typical element, and we've got an index of summation. Okay, so it's basically what I said there. So what would I do if I had to keep adding values up to x100? How would that change? Try and pause the video, try and write your answer down. Well, it would be my sum. It would be xn again, but this time I'd be going from n equals 1 up to 100. So hopefully you can see why this is such a great piece of notation. I can literally write something that's so much longer, but with almost the same amount of effort, which is really useful. Note, we don't have to use n. I could change it. I could change it to like m or something. I could change it to I, and you'll see different things used. Note also that we always keep these as integers. We never use like m is 0.1 to 100. Okay, and from this point on the lesson, I'm going to get you to play around with this. So, I've already answered this one. Okay, that's what that would give. Right, can you tell me? Oh, there's one thing I've not said yet. Like, so, no, do you know what? Just give it a go. Tell me what you think the answer to this one is. Okay, for this one, actually, n itself is the thing that's changing. It's not xn or xi. It's n. So this turns out to be 1 plus 2 plus 3 plus 4, and it's a way of writing down 10. This thing here is just equal to 10. What about this one here? Well, it's almost the same as the first one, but now my starting number is 3. So great, we don't always have to start at 1. We can just change it. This is x3 plus x4 up to 10. How about this one? Well, in this case, I'm starting at x1 squared. and then I'm adding them all up to x to the n squared. I don't know how many there are, so if I change the n to some other number like 5, yes, I'd stop at x5 squared, but this just means I'm going all the way up to xn squared. How about this one? Very similar, but this time I'm adding the x1s up to xn, and then I'm squaring it. Different things. Here I'm squaring the x's, here I'm adding them all up, and then I'm squaring. And how about this one? Very similar, but now I've got two things with these indexes. So it's x1, y1, x2, y2, all the way up to xn, yn. These are all actually frequently used things in maths. We'll cover some of them. We'll see this one and this one in particular, but the process, the principle of summation notation is what I'm trying to get across here. Okay, let's flip it round. Oh no, not quite yet. Right, just tell me the value of this one here. Okay, the answer is 100. So it's actually 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed. And this seems a good opportunity to just tell you actually your calculator can deal with things like this. So whilst I want you to have the understanding that that's what this is, you can also find a little button. It's actually Shift X and it brings up summation notation. So I can put 1 in, I can put 4 in. I'm going to have to put, because by definition in your calculator it makes X the index, I'm going to have to use X here. So it's going to be alpha X. I think it's, oops, that one outside. Okay, make sure it's in the brackets. There we go. Alpha X. Can I use that? Oh, I can use that. Okay, brilliant. I don't need to do alpha X. I can just press the X. It's part of it. I didn't actually realize that. And then I can cube it and I get 100. So that's a useful tool on your calculator to just be aware of. Okay, flipping it around now. How would I write this using summation notation? Adding the first 10 whole numbers. Okay, it's going to be similar to that n1 above. That's the possible answer. You might not have gone with n, you might have gone with k or I, but the rest of it should be the same. How about this one? You have to recognize that these are the square numbers. And so it's going to be the sum of 1 to 7 of n equals 1 to 7 of n squared. Moving on, we can include fractions in it. Again, I'm giving you the summation. What answer would I get? Okay, the answer is 1 and 13 over 30. Don't mind, okay, let's do it both ways. So it would be 1 over 3 when I put in I equals 1, plus 2 over 4, plus 3 over 5. And then you could add that up, you get 1 over 13 over 30. You could also just use summation notation here on your calculator. So I'm going to use the fraction button, x over x plus 2. Just need to change the top one to a 3. Okay, there we go. And we get that. You can change it to a mixed number by doing Shift SD. Brilliant. Okay, this one. Probably getting to the point where you just think you should use your calculator for that, but that's your answer, 110. There's quite a lot of terms to write down here. And then, finally, just introducing the idea that the summation does not have to start with 1 or 3 or 2. It could start with 0, but it could also start as a negative. So what do you think the answer to this is? Try and do this one without a calculator. So it's going to be minus 3 squared minus minus 3 plus minus 2 squared. I kind of regret saying don't use a calculator for this because it's going to be a lot. Plus minus 1 squared minus minus 1 plus 0 squared minus 0 plus 1 squared minus 1 plus 2 squared minus 2 plus 3 squared minus 3. All right, rather than calculating all of that, I can notice that this would give me plus 3. That's going to cancel with the minus 3. Basically, these little pairs are going to cancel. I don't need to work them all out. I can do if I want. The zeros are going to go completely. Minus 3 squared is the same as 3 squared, so it's just going to be 2 times 3 squared. Yeah, because I've dealt with both of them. Plus 2 times 2 squared. Plus 2 times 1 squared for similar reasons. That is just going to be 2 times 3 squared plus 2 squared plus 1 squared, or 2 times 9 plus 4 plus 1, and I think I'm going to get, that's 13, 14, I think I'm going to get 28. Okay, let's check that. Okay, nice one. Finally, here's actually where we're headed with this topic, but you'll see this again in second year at A-level. So I've decided to really kind of introduce it in detail in this lesson. How can we write down the mean of n values using summation notation? I'll give you a bit of a hint. So what, because I think you might not know quite what I mean. What if I had x1, x2, x3? These are all my values up to x to the n. How could I write down the mean of that? You might, I suppose the first question would be, how would you write down the mean of it just normally, you know? And then how could you write that as summation notation? And the answer is that you're first of all just going to add them together and then divide by how many there are. How many are there? There's n values. And we saw right at the start of this little sub-lesson that this thing here is it's sigma xn. Oh, I shouldn't use an n here because I have an n in my final answer. So it's going to be sigma xi or something like that. From I equals 1 up to n, and I'm going to divide by n. And this is a formula for the mean that you will see you'll see something similar to this on the formula book, but this is what we're doing. When you see this from now on, you'll know I'm just adding up all my x values and then I'm dividing by n. Sometimes, actually, I say sometimes, in statistics, it's simplified even further to the following. We just write sigma x over n, and it is implicit that sigma x, like capital sigma x, is exactly the same as this thing here. I just don't worry about writing the index and what I'm going up to. It's implied that I'm going to be adding up my n values. So you will see this, and you will also see it given a symbol, x bar, we call this. Now I'm not going to do any more on that today, but that's going to be straight in there next time to be able to calculate the mean, and you'll see why, because I'm going to be extending it a little bit further, but it's given. We've got summation notation and we can write the mean in terms of that. Let's take a look at frequency tables. So one is shown below. I've got some people in an orchestra and they're asked how many instruments they each play. Here are the results. And if I was to write this data out in full, this was what it would look like. I've got some people that play one instrument. And how many values do I have? I actually have 11. So I've got 11 ones. I'm not going to write them all out. And then next, I've got how many twos? I've got 10 twos. That's what that means. I've got twos and the frequency is 10. And then I've got 5 threes 3 4s, and finally a 5. That's all the listed data. Now we have looked at the fact that the mean is equal to the sum of x over n. But that, in fact, was for listed data. When I've got all my x values, I add them all up. In this case, I'd add 30 values up, and I would divide by 30. It's a slightly different tactic for when we have a frequency table, because we can do it more quickly, and we can also generalize this formula, but that's to come. So rather than adding 11 ones, what we can do is actually just multiply 11 by 1, and that will give me the same answer, 11. And what I'm actually doing is I'm doing the frequency multiplied by x, or just fx. Not f of x, by the way, but f times x, or fx. If I add all my 2's up, I've got 10 2's. It's the same as doing 10 times 2. It's going to give me 20. I've got 5 3's. I'm going to multiply that to give me 15. I've got 3 4's to give me 12. And I've got 1 5 to give me 5. And if I add all of these up, that will give me the total amount of when I add all my x's up. It's the same thing, and I get 63. You can check if you like by adding these up with a calculator. If I add all my frequencies up, then I'll actually get 30 in this case. It's this, we're actually given it at the start, but if we weren't given it, we could add them up. And that's going to be my number of values, that total frequency. And so to work out the mean, it's going to be that x bar is equal to 63 over 30. And I've done it in a more efficient way using the frequency table, and that gives me 2.1. There's a second way you can do this question that I'm now going to talk about. And that is your calculator, your Classroom's calculator has an inbuilt function for dealing with this kind of frequency table. And here it is. You go to Menu, you find Statistics, and then you go to one variable, because we're only dealing with one thing at a time here. Press 1. And what you get is something that looks a bit like this, and it's actually set up exactly the same as my frequency table, except on your calculator it might not be, because you have to turn this option on. So you can turn this option on by going to Shift Menu, so that actually takes you to Setup, and then you press down, you go to Statistics, and you turn Frequency on. I'm just going to turn it off and show you what yours may well have looked like. So this is if you just had a list of data, you could then do the same calculation. But we're going to be using this function for frequency tables. I mean, you can go either like back and forth now, but generally it helps to just have it in frequency table mode. So to get it back into frequency table mode, I've gone to Statistics to get to there. Now it's going to be to Setup. I'm going to go to Statistics, and I'm going to turn the frequency on and back where I was, and I can now just type in my values. Equals sends me down, so 1, 2, 3, 4, 5. By default, they are given a frequency of 1, so you can still use this function for listed data. It's worth just keeping it in this mode. 11, 10, 5, 3, and 1. Okay, I've filled in all my data. What do I do now? There's a little button here that says Option, and that allows you to do some calculations, and I'm going to go to one variable calculations, and there we have it. It does it all for me. It works out the mean is 2.1. It's worked out that the sum of x is 63, and it's even worked out some other things that we are going to look at later on. It even finds that the median is 2, so that's a little bonus. Oh, and it finds the maximum. Okay, so some of those we'll go look back at. For now, just be aware we can find the mean with them. We get the same answer. And so actually in A-level maths, you don't need to do all this work in. You can simply just use the frequency ability on your calculator. Okay, we're going to generalize slightly. Check out this question. Suddenly, I've got the number of instruments is x1, x2, x3, x4, x5. I want you to pause the video and think, how could you work out the mean in terms of x and f? If you're not sure, watch on, but I want you to give this a go. Because it's going to work out in exactly the same way as before. I'm going to work out the frequency times the number of instruments in each case. So I'm going to get f1, x1, f2, x2, and so on. Right, now what happens when I add all of these up? It's going to be f1x1 plus f2x2 plus blah, blah, blah. There's a really nice way we can write this. We can simply write it as the sum of fx. That is what it is. If you want to write it in full, you can say it's a sum from n equals 1 to 5 of fn xn, but it's absolutely fine to just abbreviate it, and that means exactly the same thing. And then for the frequency, we'll add up all the frequencies, f1 plus f2 plus f3 plus f4 plus f5, and I can just write that as the sum of f. If I want to do it in full, it will be the sum of fn from n equals 1 to 5. But in general, it's absolutely fine to leave it like that. And so the mean is simply going to be the sum of fx over the sum of f. For frequency tables, we get a very similar formula for the mean. We just have to make the slight modification and times by the frequency. Note is every single x is multiplied by the frequency that it corresponds with, because that gives us this value, this thing here that we need. And then we divide by the, instead of divide, we could say we divide by n, but it makes sense because everything's recorded in terms of the frequency. We're just going to divide by the sum of the frequencies. So that is a formula. I've actually forgotten as I write this whether this is given in the formula book. But here we go. If I have n values, it's exactly the same process, but I would again simply abbreviate it to this. So actually they put the x first. I would put the frequency first. I just think it makes a bit more sense. Okay, this is my general formula. I'm just summing all my n values, either the fx or f. Okay, brilliant. And building on this is going to really help us when we're going to take further strides into statistics. We're going to take a look at one other type of frequency table now, and that is a grouped frequency table. So this is used when you might have lots of different values, but you're still trying. You don't want to write out just a list of all the data. You're trying to kind of have a feel for what's going on, and so we just put it into groups. In this case, it's actually not groups of 4 though, because we need to be careful. I'll talk about that in a second, but we can still deal with finding the mean of this type of grouped frequency. Okay, and the first thing to say is these groups, well, where do I put it if I've got, say, 8.3, I measure it? Well, I need to round it to the nearest centimetre, and then that would round to 8. But I sort of need to take that into account with my lower bound and my upper bound. So the lower bound would actually be 3.5. If I measured it as 3.5, I'd round it up to 4. And then the upper bound will be 8.5. So I just wanted to recap that idea, because sometimes, especially for histograms, you need to be really careful with the class boundary. I'm not going to write any more. I've given you the idea of what's going on. Now, what we do for grouped frequency is we say, hey, I've got 2 numbers in the group 4 to 8, actually 3.5 to 8.5. Well, I don't know if they're both really low. They're going to round, they're going to be 3.5. Or maybe they're evenly spread throughout the group. Maybe they're like 5 and 7, or maybe they're both at the higher end. We don't know, but what the assumption we make is that they are evenly spread, and therefore we use the midpoint to represent the group. And the midpoint in this case, if I say 4 to 8 or 3.5 to 8.5, is actually 6, because 6 is 2.5 away from 3.5 and 2.5 away from 8.5. You get away with it in this scenario, but you might not if it was something like ages rounded. No, you don't round ages, the whole ages in whole years. You need to be a bit careful, so just be aware of that. But we can use the midpoint. We're going to get 6, 11. This one's going to be 16, then 21, 26, and 31. So that midpoint is representing the whole group, and what we've managed to do is essentially turn this grouped frequency problem into the same as before, a frequency table problem with the values for x, and this in our case the midpoint, and the frequencies as before. Now we can multiply them together and do exactly what we did, but why not just use our calculator to deal with it now? It's just going to be much more efficient. So return to menu, statistics, one variable, get your frequency table up. Note that we're now basically treating it as not a group frequency table, but a normal frequency table. So we're going to use the midpoint. Okay, such a quick method. Then put in your frequencies. I've done them all. Option, one variable, calculation, and here we go. We've got the mean. For an A-level question, this would not be worth many marks, so the best thing to do is just do it really quickly. We get 825. We would divide by the sum of the frequencies, but I'm just going to literally write down the X bar is 20.625. Now, just before I write my final answer, I should think about the degree of accuracy that I can give this to. It is an estimate. I've already forgotten what it was. Was it 26? 20. So the best I can do really is round it to 3 significant figures, and even that might be a bit much. So 20.6 centimeters. And we're done. So slight different addition. We are still using the idea that now X bar is the sum of Fx over the sum of F. Okay, my calculator is dealing with all that for me, but that is going on. We use the midpoint to represent it. We can deal with the mean of frequency tables and grouped frequency tables.